This video is going to go through the examples on the extra notes page in lesson 1.4. This is day 1, so these problems will focus on solving systems of linear equations with graphing and substitution. Example 1 wants us to tell whether the ordered pair is a solution of the system of linear equations. Remember, for an ordered pair to be a solution, it has to make both equations true. So that's what we're going to do here. We're going to plug in our x and y values to see if it makes each equation true. So here's my x value, here's my y value. I'm going to substitute these in. So for the first equation, I'll plug 2 in for x and 5 in for y. And I want to know, is this true? Well, 2 plus 5 is 7, and 7 equals 7. That's true. Now I'll plug 2 and 5 in for x and y into the second equation. So 2 times 2 minus 3 times 5. And I want to know, does that equal negative 11? So I have 4 minus 15. And yes, that's equal to negative 11. So that ordered pair makes both equations true. So we would say yes, the ordered pair is a solution to the system. Part B, we're going to do the same thing. Our ordered pair is negative 2, 0. And I'm going to plug negative 2 in for x and 0 in for y. So for the first equation, when I plug those values in, I get is 0 equal to negative 2 times negative 2 minus 4. Well, negative 2 times negative 2 is positive 4, and 4 minus 4 is 0. So that does make the first equation true. Now I'm going to check the second equation. I'm going to plug 0 in for y and negative 2 in for x. This is not true. 0 is not equal to 2. So this ordered pair does not make the second equation true. So we would say no. This ordered pair is not a solution. In example 2, wants us to solve the system of linear equations by graphing. So remember, when we solve by graphing, we're going to graph both lines, and we're interested in where those two lines intersect, because that point will be a point on both lines, which means it is the solution to the system. So we first need to remember how to graph these lines. Okay, let's graph y equals negative 2x plus 5. 5 is the y-intercept, and negative 2 is the slope. Remember, these are in the form y equals mx plus b, where m is the slope and b is the y-intercept. So I'll start at the y-intercept of 5, and I'm going to count to another point on the line using a slope of negative 2. Think rise over run. So I'll count down 2 and right 1. Down 2, right 1. Down 2, right 1. And you could keep doing this until you got enough points to make it easy to graph the line. Now I'll graph the line y equals 4x minus 1. 4 is the slope. Negative 1 is the y-intercept. So I'm going to start at the y-intercept of negative 1. This time with a slope of 4, I'm going to count up 4, right 1. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. Now that I have both of my lines graphed, I'm looking for where they intersect. They intersect here at the point 1, 3. So the solution to this system is 1, 3. We're going to go ahead and skip example 3 on the bottom of the first page. And these 3 on the back, we're going to be using substitution to solve these systems. So when we solve by substitution, our goal is to substitute one variable into the other to get the variables to eliminate. So you're looking for one of these equations to be solved for x or y. So my first equation tells me that y is equal to negative 2x minus 9. So what that means is in my second equation, wherever I see a y, I can substitute negative 2x minus 9 in for y. So I'm going to take my top equation and substitute it into my bottom equation. When I do that, I'm going to rewrite my new equation. So 6x minus 5. Now remember, when I plug this in for y, I want to put it parentheses around it because I'm substituting the whole thing in for y. So you can see when I substitute the top into the bottom, my y is now gone. And now I have an equation with one variable. So I can solve this to get x. I see that I can use the distributive property here. I'm going to distribute that negative 5. So 6x negative 5 times negative 2x is positive 10x. And negative 5 times negative 9 is positive 45. I have some like terms. I can combine those terms to get 16x. I'm going to subtract 45 on both sides. And then divide both sides by 16. And I got x equals negative 4. Now I'm not done. Remember, when I solve a system, I need my x and y value. Right now I just have my x value. I still need y. So now that I know x, I can take that x value and plug it back in to my other equation. So I can take negative 4 and I can substitute it back in for x. So y is going to be equal to negative 2 times negative 4 minus 9. And I get that y is equal to negative 1. So there's my solution to the system. In example 2, they want us to solve by substitution again. If you're looking at each equation, though, you'll notice that there's a problem. Neither of these are solved for x or y. So unlike example 1, where y was this was solved in terms of y, this is not the case. And so the first thing we want to do is solve one of the equations for x or y so that we can substitute it into the other equation. This top equation looks pretty simple to solve for y. So I'm going to take this top equation and I'm going to get y by itself. So all I have to do is get rid of this negative x on the left side by adding x to both sides. And this new equation, solve for y, is equal to y equals x plus 3. Remember, do not add these together. These are not like terms. Okay. So now I'm going to consider this to be equation 1. It's just rewritten. I'm not going to use this one. So now, since this is solved for y, if y is equal to x plus 3, I can take x plus 3 and substitute it in for y into my second equation. So my second equation, 3x plus x plus 3 is equal to negative 1. And I'm going to solve this for x. I have some like terms. Subtract 3 on both sides. Divide both sides by 4. I get x is equal to negative 1. Now, again, I need to still find my y value, so I can go ahead and take my x value and plug it in for x. So y is going to be equal to -1 plus 3. So y is equal to 2. My solution to the system is -1, 2. All right, our last problem. A drama club earns $1,040 from a production. A total of 64 adult tickets and 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents this situation. What is the price of each type of ticket? Whenever you are writing equations and you're going to solve a system, to help you out, ask yourself, what is it that I'm trying to find? I'm trying to find the price of each type of ticket. The thing you are trying to find, that is what your variables will represent. So you're trying to find the price of an adult ticket and the price of a student ticket. So first, I'm just going to define my variables. So I'll let A be the price of adult tickets, of one adult ticket. And I'll let S be the price of a student ticket. So to help you define your variables, ask yourself, what is it they want me to find? And that will be what your variables are. And this will help us figure out how to write our equations. So first they tell us that a total of $1,040 is earned. So I know one of my equations is going to use this total. And so I got to think, what is going to get added together to get a total of $1,040? Well, they tell me that 64 adult tickets were sold and 132 student tickets were sold. Well, I can use this and my variables to help me get the total cost. Right? So the price of all the adult tickets will be 64 times A, the price of one adult ticket. Right? 64A, this represents the cost of all the adult tickets, or the total of all the adult tickets. And if we add that to the total money made from the student tickets, that would be 132S. Right? The price of one student ticket times 132. And that's going to be equal to the total that was earned. So this first equation represents the total amount of money earned from this production. My second equation, I have to look at what else I know. It tells me an adult ticket costs twice as much as a student ticket. So one adult ticket A is, think of that as an equal sign, is twice as much as a student ticket. It's 2 times the amount of a student ticket, or it's 2 times S. So these are my two equations. This is set up nicely for substitution because notice equation 2 is solved for A. So what I can do is I can take 2S and substitute it in for A in the top equation. So I'm going to rewrite equation 1 with 2S substituted in for A. 64 times 2S plus 132S equals 1,040. I'm going to solve this equation to get S, the price of a student ticket. So I have 64 times 2 is 128. I'm going to combine like terms. Then I'm going to divide both sides by 260. And I get S, the price of one student ticket is $4. I still need to know what the price of an adult ticket is. So now I'm ready to go back and plug this value of 4 in for S. So the price of an adult ticket will be 2 times that amount. right? Because adult tickets are twice as much. So the price of an adult ticket is $8.